Designation and development.
Yes, good evening, dear participants. Am I audible?
हाँ जी सर, हाँ जी।
Yes. Sir,
सर माइक ऑन कर लीजिए सर। पंकज सर, द माइक ऑफ है।
okay. So I welcome the participants in the second session. So the first session, resource person Dr. Sarbjeet sir will continue the second session. So it was a wonderful talk he has delivered in the form of the practical exposure as well as the case studies while responding the very curious, very appropriate queries from the participants. So I welcome the resource person Sarbjeet sir. And sir, if it is comfortable to continue the second session, or some break is required to be further extended.
No, sir, I think we can continue, sir.
Right, sir. Right. So, sir, now you can continue this talk.
All
Thank you,
right,
sir.
sir. All right. Thank you. Thank you, sir. So, sir, I hope the screen is visible and I am audible.
Yes, sir.
यस
You
सर।
are audible, and
Okay.
screen is visible too.
So, good evening, all the participants once again. So, let's start the second session, which is about AI and machine learning, exploring their diverse applications. So, let's start the discussion. So in the very first slide, we'll try to understand the different terms which are in common use nowadays: AI, machine learning, data mining, deep learning, and data science. And we'll try to see what is the main focus of each of these terms and how these terms are interlinked with each other. So see, artificial intelligence is the study of intelligent systems and algorithms, and it enables machines to perform tasks that typically require human intelligence. For example, if we talk about talks like reasoning, learning, problem solving, perception, natural language understanding, then all these tasks fall under the umbrella of artificial intelligence. So in this sense, AI deals with building systems or machines that can think, learn, reason, and behave like human beings. And it encompasses a broad range of technologies designed to simulate the human intelligence. So I think these terms, these key points wherein we are saying that we are trying to build systems and machines which can think, learn, reason, and behave like human beings. This is very broad, and this is the subject matter of artificial intelligence. And that's why the things like reasoning, learning, problem solving, perception, natural language understanding, all these things fall under the area of artificial intelligence. Second term is data mining. Data mining is the study of methods and techniques for discovering meaningful patterns. Not only meaningful patterns, but trends and insights from the data. And for this, data mining uses statistical, mathematical, and computational techniques. So in short, what we can say that data mining deals with discovering patterns from data that are previously unseen. So see, the focus has changed now. There may be overlapping in the concerns in the areas, but see the main focus, the major focus. The major focus of data mining is to discover patterns from the data that are previously unseen, wherein AI is trying to construct such kind of machines which can think, learn, reason, and behave like human beings. Machine learning is the study of algorithms and statistical models that enable systems to learn pattern or insights from data and make predictions. And for this, the system is not explicitly programmed. So in this sense, machine learning deals with learning from data and use the learned knowledge to build models for making predictions on data. Now see, here the central theme, central idea. Learning from data and use the learned knowledge to build models for making predictions on data. So making predictions is the main focus in machine learning. Discovering patterns is the main focus in data mining. Building system which can think, learn, reason, and behave like humans is the main focus of artificial intelligence. We also, commonly use the term deep learning. Now, deep learning is the study of neural networks and algorithms that mimic the structure and function of human brain to automatically learn and extract intricate patterns and representations from vast and complex datasets. In short, neural networks deal with learning from data through neural networks and automatically discover intricate patterns and relationships from the vast and complex data. So here, if we look at the main points, so deep learning is dealing with learning from data through neural networks. So the main entity, main key characteristic is we are utilizing neural networks and to automatically discover intricate patterns. And we all might be knowing that, yes, feature engineering is happening automatically in deep learning. So automatically discovering intricate patterns and relationships from vast and complex data. This is the subject matter of deep learning. We also commonly use the term data science, which is basically a multidisciplinary field. Multidisciplinary field that uses the concepts and methods from mathematics, statistics, artificial intelligence, data mining, machine learning, and other related technologies to extract knowledge and provide insights to data in various forms. So in data science, we basically say this is multidisciplinary field. And it is utilizing the concepts and methods from mathematics, statistics, AI, data mining, machine learning, and other related technologies with the ultimate goal to get insights to data in various forms. So in short, AI deals with building such kind of machines and systems which can think, learn, reason, and behave like human beings. Data mining, major focus is on discovering patterns from data which are previously unseen. Machine learning, major focus is to build models for making predictions on the data. Again, this does not mean that we cannot make descriptive models. Descriptive modeling is also done. Deep learning, wherein we are learning from data, but with the help of neural networks. And those neural networks are automatically discovering the intricate patterns and relationships, and they are acting on vast and complex data. Data science, which is a multidisciplinary field and utilizing the concepts from AI, data mining, machine learning, mathematics, statistics, deep learning, and other related technologies to extract knowledge and provide insights to data in various forms. So this is how these terms are interconnected with each other. Now, this slide shows the AI, machine learning, deep learning, data science, natural language processing, computer vision, ecosystem technology stack. And see, this comprehensive stack empowers a diverse set of applications. Applications spread across different fields like business, banking, finance, medicine, pharma, healthcare, government, agriculture, science, engineering, and so on. And see, artificial intelligence consisting of, machine learning, further consisting of deep learning, and we are, working on technologies like robotics, cognitive computing, data science, big data, natural language processing, computer vision in this domain. And we generally, study these subjects. So if we are dealing with this ecosystem in one or the other way, we would be studying, AI, machine learning, deep learning, NLP, computer vision, robotics, knowledge representation, cognitive architectures, neural networks, reinforcement learning, sentiment analysis, speech recognition, speech synthesis, emotion recognition, contextual understanding, ontologies, multimodal interactions, VR, augmented reality, virtual reality, big data analytics, ethics and responsibility in AI is also, has become the, major area of concern and major area of study nowadays. So this is just a big picture, like how this artificial intelligence, machine learning, deep learning, data science, NLP, and computer vision is empowering a diverse set of applications. And now we'll look at, those application areas individually also. But before that, it is also important to, understand, the growth of data that has happened in the previous decade. So this next slide basically shows the growth of data from 2010 to 2025 in zettabytes. So this the units are the zettabytes. You can see. And the growth from this 2010 to 2025. So probably this single most important factor that has accelerated or speeded up the development of artificial intelligence, machine learning, and deep learning technologies is the growth of data. See, very simple. If we don't have the data, we cannot learn anything. We cannot, actually utilize machine learning, deep learning, and these kind of system. Why? Because first of all, they require vast data to learn from. So only thing, the single most important factor that has accelerated or speeded up the growth and development of AI is the growth of data. And you can see in this slide that the global data is growing exponentially. It is not linear. The growth is not linear. The growth is exponential in nature. And this growth is primarily driven by the rise of internet, IoT devices, social media, mobile devices, and other aspects of digitization of our daily life. So only because of these things, internet, mobile devices, and digitization of every aspect of life, this data growth has reached this exponential level. And the data generated in this period is diverse also. It is diverse and unstructured. Unstructured means it consists of images, audio, video, text, and many other modalities. And moreover, the data is being generated in a real time. It is getting by the generated and the social media 24/7. And really, very clearly, such kind of data will present challenges to the traditional methods. If we talk about, traditional ways of handling the data, the way, DBMS and RDMS was handling the data, that is not sufficient and scalable now. And we need, the means and mechanisms to handle unstructured data. And that's why, the databases like MongoDB and Cassandra has grown up. And really, these things have propelled the research in AI, machine learning, and deep learning as well. Why now? Because now we have the access to the data. We have access to the vast amount of data, and that data is unstructured. That data is diverse. The data is existing into multi modalities. The data is getting generated by social media or sensors 24/7. So that's why these technologies are maturing naturally. And now in today's time, compute power is not an issue, storage is not an issue, communication technologies are not an issue. But if you go 10, 15 years back, still we had concerns about the compute power, about the storage, about the communication technology, because still going through 2G, 3G kind of technologies. But today's, communication technologies have matured. We are talking about 5G, 6G, and higher generation, communication technologies. The increase in volume, variety, and complexity of data has also directly contributed in the acceleration of artificial intelligence, machine learning, and deep learning technologies. And generative AI is also happening because of that. You see, if you look at the kind of system like Chat GPT and other similar system, they have been trained on vast, very very vast amount of data. They are learning billions of parameters. That is only possible because we have the data available now. And this slide, highlights just that aspect, that the single most important factor, the growth of data that has propelled, accelerated, or speeded up the development in AI, ML, and deep learning. Now, if we talk about the application areas, the few forthcoming slides would be telling about the different application areas of AI, ML, and DI technologies in different fields. Like if we talk about the field of business, banking, and finance, then these technologies can be utilized for product recommendation, movie recommendation, shopping recommendation, and recommending like which food to buy. Then segmenting customer into groups like parents, youngsters, bookworms, games, artists. This can also be attempted with these technologies. Fraud detection in transactions, predicting the value of a fund in share market prediction, automatic customer feedback classification, like whether the customer has given a complaint or whether the customer is praising you. This become the subject matter and application area in the field of business, banking, and finance. And if we talk about the field of medicine, pharma, and healthcare, then these technologies can be utilized for the classification and prediction of medical complications, precision medicines, or personalized treatment. Learning electronic health records data, because nowadays we have started maintaining electronic health records as well. Prediction of epidemic outbreak, drug discovery. This is also another very important application area of AI, ML, and deep learning technologies. Prediction of success rate of a drug, classification of tumors as being malignant or benign, recommending age by which a person should go through medical test, recommending dietary changes. So see, all these are very very meaningful applications in the area of medicine, pharma, and healthcare. Then if we talk about government in the field of good governance, the technologies can be used for the classification and prediction of crime, criminal detection systems, or smart policing system. Then classification and prediction of traffic patterns. So we say the smart traffic management, classification and prediction of census data, decision support system, smart policy making, classification and allocation of funds. That means to say smart financial management, another very important area, application area of these technologies. Learning citizen feedback for classification and predictive analysis for citizen issues or problems. Smart citizen outreach, electricity consumption prediction, electricity demand forecasting. So see, again, all these are again very, very important application areas in the field of good governance. Then if we talk about the area, the field of agriculture, then these technologies can be utilized for precision agriculture, for classification and prediction of plant diseases, spotting disease types, its severity or likelihood of occurrence of diseases in the crops or plants, diagnosing pest or soil defects, identifying and predicting of patterns between fertilizer usage and increase or decrease in crop yield. Learning right crop timing, again very very important application area. Classification of soil, prediction of harvest time. So again, see, in the field of agriculture also, this AI, ML, and deep learning technologies have a lot of potential to contribute. Then in the field of science and engineering, so these technologies can be utilized for DNA sequence analysis, discovering planets or new particles, understanding stars, earthquake predictions using seismic data, weather forecasting or wind forecasting, carbon emission pattern classification, making predictions on global warming. So again, all these are very meaningful, significant application areas in the field of science and engineering. And in general, other applications, these technologies can be utilized for classification or clustering of friends into photo albums, digit character or face recognition, automatic organization of emails into different folders, the spam detection and filtering, topic modeling, sentiment classification, classification of behavioral patterns, identifying topics in a set of blog spots, automatical identification of topics, anomaly detection, emotion detections. So see, in fact, the list is still, endless. This is just a partial or a incomplete list of application areas. So in fact, these technologies have impacted each and every life of each and every aspect of human life. Now, again, although we are talking about AI, ML, DL, and data science technology, the question is, should we use them for each and every kind of applications? So the major question, faced by the practitioner is like, when should one use these technologies? And the answer is that when designing and programming explicit algorithms with good performance is difficult or infeasible, then you should switch to AI, ML, DL, or data science technology. So this is the answer. When designing and programming explicit algorithms with good performance is difficult or infeasible. So now from now onwards, we'll be taking a difference between learning and explicit programming. So there's a difference between the way program learn and explicit programming is done. So if we are building a system, let's say for spam email classification, recommendation system, or we are trying to recognize an email, that will come under then these systems, these types of system solutions would be attempted with learning approach. But if we are trying to build a system, let's say a banking transaction system, missile guidance system, where each and everything is very well defined and the mathematical equations are readily available, they just need to be coded in a programming language, then in such area, in such cases, one should do explicit programming. Similarly, reservation systems like airline reservation, hotel reservation, for these systems, probably the explicit programming approach is better than learning approach. So try to understand the nature of these problems. Like for spam and email classification, recommendation system, image recognition, we cannot write explicit programs. But for banking transaction, missile guidance system, reservation system, these explicit programs can be prepared, can be written, and hence this explicit programming approach is required. So one should not blindly try to apply AI, ML, DL, and DS technology to each and every problem, but rather the problem should make sense for its exploitation by this AI, ML, DL, and data science technologies. Now, the major concepts involved in the study of these systems are learning, supervised and unsupervised learning. And in general, learning is the process of acquiring knowledge through experience or data. So see, this is the basic requirement. If you want to work on any machine learning project or application, you need the data first. And data is the mean and mechanism via which the knowledge or experience would be acquired by the algorithm, and it will get the ability to learn and then make prediction on the future instances of data. So in that sense, the learning is the process of acquiring knowledge through experience, and experience comes when we feed data to the learning algorithm to learn from. And primarily, there are two different paradigms to learning: the supervised learning and unsupervised learning. Supervised learning is a type of learning where a model is trained using data that has both inputs and the inputs and the correct answers labels. So this is the main idea, the key characteristics of supervised learning. The model is trained using data that has both inputs and correct answers or labels. Like we already tell to the algorithm that if this is the output, this is the output it should produce. If this is the input, this is the output the algorithm should produce. So the model learns from this data, and it can make accurate predictions when given the new or similar data. So it's something like, learning with the help of a teacher who provides the right answer during training. And clearly, in supervised learning, the data is labeled. The labeling is the learning signal that the algorithms try to exploit, and then later on come up with the predictive models that can be utilized for making predictions on the future instances of data. Unsupervised learning, on the other hand side, is a type of learning where the model is given data without any correct answer. So you see, this is the main characteristics. The model is given data without any correct answers. But here, the algorithm was getting both inputs and the correct answers. So in unsupervised learning, the model tries to find patterns or groupings within the data on its own without, utilizing labels, because labels are not present in unsupervised learning. And unsupervised learning happens without any guidance. So it's like learning without a teacher and figuring things out by discovering the patterns. So the philosophy is clear from their names itself. Supervised, like it's learning with the help of a teacher. Unsupervised, like learning without a teacher, and the algorithm has to figure out the things at its own by discovering the patterns inside the data. Now this slide grammatically shows the difference between a labeled data set and a unlabeled data sets. So this is a sample play tennis data set that tells us whether one should, play tennis outside or not. So interpretation is very simple. If outlook is sunny, temperature is hot, humidity is high, wind is false, then one should not, play tennis outside. But if outlook is overcast, temperature is hot, humidity is high, wind is false, then one can, uh, play tennis outside. So, this play tennis, this is the learning signal. This is something which is making this data set labeled a data set. And if this kind of data set is fed as an as input to the learning algorithm, really the learning algorithm can give you a predictive model that can be utilized for making predictions on the future instances of data. But this data set, this data set is not labeled. This is unlabeled. See, we are just given the access to feature. We are just having, the features like outlook, temperature, humidity, and windy, but we have no target feature to learn like it was available previously in the previous. So very very simple concepts, to demonstrate the difference between a labeled data set and a unlabeled data sets. And if we try to, categorize learning, we already talked about that learning can be classified as a supervised learning and unsupervised learning. So supervised learning happens with the help of labeled data. Unsupervised learning happens with unlabeled data. And we have a third category also, which is the reinforcement learning. So reinforcement learning basically, uses the concepts of penalties and rewards. So what happens in reinforcement learning, whenever a model makes some prediction, some feedback is given to the model. Whether the output produced by the model is good or bad, correct or incorrect, right or wrong. And based on this feedback, then the algorithm, the model makes certain changes in it. So if it produces correct or right output, some reward is given. But if the model produces incorrect or a wrong output, then some penalties are imposed. And via these reward and penalty mechanisms, where the ultimate goal is to maximize the cumulative reward the model tries to learn. So this very idea of rewards and penalties is utilized in reinforcement learning. But in supervised learning, unsupervised learning, there is no explicit concepts of rewards and penalties. And we will also see that regression and classification are the examples of supervised learning task. And clustering and dimensionality reductions, these are the examples of unsupervised learning task. And reinforcement learning applications like driving, self-driving, wherein car needs to drive at its own, those kind of systems can be attempted with the help of reinforcement learning technologies. And this slide diagrammatically, shows you the concept of classification, which is basically the process of categorizing data instances into one or more categories or classes. And in classification, we all know the output variable is discrete. And already mentioned, classification is a supervised learning task. It requires the labeled data to learn from. And in this diagram, you can see there are two kinds of dots, the green one and the blue one. So these are representing two different classes of observation. And in classification, our task is to separate these two sets of observation, that is separating these green observations from these blue observations. So if this is the kind of task you are attempting, then we say this is a classification task. Very simply, the process of categorizing data instances into one or more categories called classes. And examples of classification tasks, you see categorizing emails as spam or not spam, categorizing tumors as malignant or non-malignant, categorizing customers as fraudulent or honest, categorizing movies as comedy or drama or action movies, categorizing credit card transactions as fraudulent or legitimate, categorizing news article as political, sports or entertainment, categorizing customer reviews as positive, negative, neutrals, images as cats, dogs, or birds, categorizing health records as healthy, pre-diabetic, or diabetic, categorizing plants as flowering, non-flowering points, categorizing customer support tickets as, the technical billing or general inquiries, categorizing online products as electronic clothing. All these are the examples of classification tasks. Then the major classification algorithms are, you might have heard the name logistic regression, K nearest neighbor, naive Bayes, support vector machine, decision trees, random forest, gradient boosting, XGBoost. All these are the examples of classification algorithms. Another important supervised learning task is regression. And regression is the process of predicting a continuous output variable based on input data. Now, unlike a classification where the output is discrete class, regression deals with numerical values. And it aims to model the relationship between the input variables and the continuous output. So you can see from this diagram also, here in regression, we are trying to fit a line given a set of observations. So given a set of observation, identifying a line that is describing that pattern is nothing but the regression task. And it is a supervised learning task that require labeled data where the goal is to find a function of the form, see this one, y is equal to fx, that best fits the data to make accurate predictions for a new and unseen instances. And this is a sample data set for regression tasks. You see in regression tasks, we are given a set of features like parameters x1, x2, x3, and our goal is to find a function of the form y is equal to fx, where this capital X is a vector consisting of these three scale these three variables, that is y as a function of x1 and x2, x3. This is our goal. So in regression, we try to find this function from this kind of label data. So in the labeled data, you are already given like if these three are the parameter values, then this is the output value. So like if you know the input values are 3, 2, and 7, then the regression must produce 7 as the output. So this data set is learned by the regression task. So regression algorithms are obviously different from classification algorithm, because in classification you are dealing with discrete output, and in regression we are dealing with continuous output. So obviously the algorithms are going to be different, but ultimately we get a function of the form y is equal to fx, which can be used for making prediction on the future instances of data. Like in future, if you encounter different values of these parameters as 9, 6, and 5, we'll ask the regression model to tell us like what is the output corresponding to these given values corresponding to 9, 6, and 5. So, and if you have really found such a function, that function will tell us like what is the value in this case. Now, examples of regression tasks include predicting a person's salary based on their year of experience, education level, and job title, forecasting the stock price of a specific company based on historical stock, market data, and economic indicators, estimating a car's resale value using factors such as what is the age of that car, mileage, make, and model. Then predicting a student's final exam score based on their previous test score, study hours, and attendance, forecasting the annual revenue of a retail store based on historical sales data, marketing spending, and location. So again, see, all these are very good examples of regression tasks. And one thing to note is that in each and every case, we are predicting a continuous value. See, predicting a salary is continuous number. Forecasting the stock price is a continuous, dealing with continuous values. Estimating the car's resale value. So this is also a number. Predicting the student's final exam score. This is also a number. Forecasting the annual revenue. So all these are numbers. In regression, we are predicting the numbers. Similarly, estimating the energy consumption of a household based on the number of occupants, square footage, and weather conditions. Predicting the price of a used smartphone based on its age, brand, storage capacity, and condition. Forecasting the demand of a specific product based on historical sales pricing and marketing effort. Estimating the time it takes to complete a construction project based on factors like project scope, available resources, and weather conditions. Predicting a patient's hospitalization cost based on medical history, age, and problems. So all these are also the examples of regression tasks, and very meaningful and good examples of regression tasks. And if we talk about, the regression algorithm, the major regression algorithms include the linear regression, the polynomial regression. We also have Bayesian regressions. These support vectors can also be utilized for regression tasks. So in the form of support vector regression. So support vector is not only a classifier. Support vectors based methods can be utilized for doing regression tasks as well. We have nearest neighbor regression also. See, nearest neighbor is a classifier, but nearest neighbor can also be, the approach idea can also be utilized to perform regression task as well. Similarly, we have, the decision trees regression. We have random forest regression, and these system have their corresponding classifier version also. Already mentioned support vector classifier, support vector regression. Nearest neighbor classifier, nearest neighbor regressions. Decision tree classifier, we have decision tree regression. Random forest classifier, we have random forest regression also. So the idea can be exploited just in the sense whether you want to come up with some discrete output, or whether you want to come up with some continuous output. And third, very common, very important task that we commonly do under machine learning is clustering, which is basically an unsupervised learning task. So clustering is the process of organizing data points, that is data instances or set of observations, into groups in such a way that the data points within the group are similar to each other in some way and dissimilar to data points in other clusters. So you can see, like if this is the kind of data set, then it is expected from the clustering algorithm that it should come up with these three kinds of clusters. Now you see, the data points within the clusters are similar to each other. and data points in other clusters are dissimilar. So if we compare the data points of this cluster with data points of this cluster, then they are going to be dissimilar. In other words, the principle of maximizing the intra-class similarity and minimizing the inter-class similarity, this is followed in a clustering process. This is a very important. The principle of maximizing the intra-class similarity, that is the items, the observations, the data points within the cluster should be similar to each other, and minimizing the interclass similarity. If we are considering the data points or set of observation between two clusters, then they should be, as much dissimilar to each other as possible. And very important, the clustering is an unsupervised learning task. And if we talk about the applications of clustering, and the examples are like segmenting customers into groups such as parents, seniors, youngsters, bookworms, artists, based on their purchase history and demographic info. Very, very important application of clustering. Organizing documents by types such as news article, research papers, blogs, and product reviews based on their content and textual information. See, previously also we mentioned in classification also that documents can be classified as one of the different categories. But in that case, we are considering that the data set is labeled. But one need to understand that when we are talking about the clustering task, and still when we are saying we want to organize documents by type, here we are talking about unlabeled data set. The data set is not labeled, but still we want to categorize the document as like news article, research papers, blogs, or product reviews. Similarly, clustering social media users into categories like they are influencer, they are fitness enthusiasts, these are foodies, travelers, passionates based on their post and interest. This is also good example of clustering task. Grouping web users into clusters based on their online behavior. Clustering, patients into healthcare categories like high risk patient, moderate risk patient, low risk patient based on their medical history and health indicator. This also becomes another very good example of clustering task. Then again, organizing, products inventory into categories like electronics, clothing, home appliances. Segmenting website visitor into cluster based on their navigation patterns, grouping news articles into topics like political, sports, entertainment, and so on, clustering sensor data from IoT devices to identify patterns and anomalies, organizing vehicle traffic data into cluster to study traffic flow, congestion patterns, and optimize transportation structures. So again, all these are very meaningful, significant, good examples of clustering tasks. And the major clustering algorithms include, the algorithms like k-means clustering, agglomerative clustering. We also have a Birch clustering algorithm, stands for balanced iterative reduced and clustering using hierarchy. We have dbScan, which stands for density based spatial clustering and of applications with noise. Optics algorithm, ordering points to identify the clustering structure. So all these algorithms can be utilized. So this is the summary of different classification tasks, so different machine learning tasks. So you will see in machine learning setting, most of the time we are either doing classification or doing regression or clustering. Classification, regression, clustering, these are the most commonly used tasks in the field of machine learning as of now. And again, summary wise, classification, the process of categorizing data into instances, categorizing instances into one or more categories. Examples are given, but in classification, output is discrete and it requires a labeled data set. Regression is also a supervised learning task, but the output is continuous and it also requires a labeled data set. Clustering, the data set is an unlabeled, and here in clustering, we organize the data instances into groups. So again, as I already mentioned, that the grouping is done in such a way that the data instances within the group should be similar, but the data instances in different groups should be dissimilar to each other. And this diagram pictorially, differentiate between the classification task, the regression task, and the clustering sort. So see how in classification we are trying to, separate the two sets of observation. In regression, we are trying to fit a line, and in clustering, we are trying to identify the different clusters or groups of the data. And in any machine learning task, if you have to feed data to the algorithm, the data is input to the algorithm in a tabular form. And we all already know in a tabular format we have the entities like rows and columns. Columns represent nothing but they represent the features, and rows are also terms and instances and data types. So this is typically how the data is fed to the learning algorithm. This is a sample loan application data set, and again a label data sets. Just for illustration purposes we have included. Then this is a sample, a house prediction data set. This is again supervised learning, but this is a regression task. So this is, see how we can, this data set can be utilized to predict the prices of a house. So this very portion of the data set is labeled. This is labeled a data set. This is learned by the regression algorithm, and once regression happens, the model is learned. We can make predictions for the house price of a new house. So if we have a new house with 1800 square footage, 4 bedrooms, 3 bathrooms, and 10 is the age of house, then we ask the regression algorithm to tell us the approximate price of this house. Other important concepts in machine learning are the concept of training data set, test data set, and validation data set. See, training data set is that part of the overall data set that is reserved for learning the properties of the data set. So you see from this diagram that if we have a full data set, then we split that full data set into the training part and the test part. And the purpose of the training set is that we would be utilizing these data sets for learning the properties for the training purpose only. Here we may ask the question like what is the utilization of the test data set? See, with the training data set we are learning a model, and once the model is built, we need some means and mechanisms to comment on the performance of the model. And that can be done only if you have some data available with you for which you already know the ground truth. So that's why we have to keep some data set as the testing data set. So in that sense, test data set is that part of the overall data set that is reserved for examining the performance of the learned model. So this is the underlying concept why test data set needs to be separated from the training data sets. We need test data set for examining the performance of learning, that is testing. So in that sense, test data set is that part of the overall data set which is reserved for examining the performance of the learning. And sometimes out of the training data set, another data set is reserved, which we term as the validation data set. So validation data set is a sample of the data which is held back from the training data set. This is important to understand, that validation set is held back from the training set to provide an unbiased evaluation of the model fit on the training data set while training model hyperparameters. So let's say with the training data sets, we are building a model, we are trying to fine tune a model, and for to fine tune that model also we need a small test data sets, because the term test data set we have already reserved at a higher level. So during training time also, if you encounter a similar situation, you need some data set for some testing, but only for this training set, then that data set we term as the validation data. So in general, this validation data set is used for hyperparameters tuning. And again, if we would be, let's say, utilizing some machine learning library, let's say scikit library in Python for doing the machine learning task. So you will see we would be, utilizing some method to split our data set into training part and test part. And most of those methods, give us 4 divisions of our data set, like training part, test part, ground truth of the training part, and ground truth of the test part. So this diagram pictorially represent that very aspects. So as you see, we here have the overall training data. We have the overall data set, and here we are splitting the data set into 2 portions: the training part and the test part. So in this case, 80% of the instances we are utilizing for the training part, and 20% of the instances are being utilized as test data set. And further, we split, the training part and test part into two components, like the features of the training data sets and the ground truth of the training data. Similarly, the features of the test data set and the ground truth of the test data set. And training happens like this with the help of, training data. We apply machine algorithm, learning algorithm, which give us some model, and then test data set is fed to this model, and which gives us some prediction results, and these prediction results are also the indicator of the performance of the algorithm. And again, when talking about machine learning system, we encounter, we use concepts like, overfitting and underfitting. So overfitting basically is the phenomena wherein the learn model fits the data too closely, and when overfitting happens, the test set performance becomes considerably lower than the training set performance. So let's say you have, built a model, and model is exhibiting the characteristic like the training set performance is 99.5% and test set performance is just 80%. So if this is the case wherein the training set performance is very high, maybe 99 or 99.5 or 98% also, but the test set performance is significantly lower, like maybe 75 or 80%, then that indicates the overfitting. And underfitting is also there. Underfitting is the phenomena wherein the learn model fails to fully capture the predictive power of the data. Means the learn model is very simple. The learn model is so simple that it results in poor training set performance. And this is very important diagram, the trade-off of model complexity and against the training and test set accuracy. See, in machine learning settings, whenever we are training the model, we are always looking for the model that is balancing, that is giving us a balance between, the training set accuracy and the test set accuracy. That means to say we are looking for this sweet spot. Now, here in this diagram, if you look at the x and y axis, see, x axis represents the model complexity. Like here at this end, we have simple model, and here at this end, we have the complex model. And if we look at the y-axis, here we have the low accuracy system, and here we have the highly accurate system. Now, what happens, to the training data in case of underfitting? See, underfitting is something you are creating very simple models, and they are yielding low accuracy also, both on the test data and the training set data. And then see the case of overfitting. What overfitting mean over here? That the model is very complex, and it is yielding high accuracy on training data, but very low accuracy on test data. So this is the gap that becomes prevalent in overfitting, and this is the gap that we want to decrease. So you see, this is the area wherein the training and test set performance is reasonable, and the gap is less. So you see, the training set performance is not so high, and test set performance is also not very high. So striking a balance between training set accuracy and test set accuracy is the major concern. And yes, of course, there are techniques around that, like the one who have worked with the machine learning algorithm might realize that grid search kind of techniques are available that can be utilized to come up with a such models that give you a good balance between the training set accuracy and the test set accuracy. And this is a typical machine learning pipeline process that we follow in any machine learning project or any machine learning application. Like we start with the data acquisition. Now in real practical scenarios, the data would be coming from different sources. The data would be coming from data warehouses, from RDBMS. It may be coming from sensors, from IoT devices. It can come from anywhere. And once you acquire the data from different sources, you need to consolidate that data. And once you consolidate that data, you see that there are different concerns with the data, and we enter this data cleaning phase. Because if you are collecting data from different sources and you are consolidating that data, you will realize that many a times the data has missing value, that the data may be having inconsistent values, the data may be having having certain irrelevant attributes also. So these missing values, irrelevant attributes, redundant values, inconsistent values, all these are the examples of dirty data, noisy data, and that needs to be cleaned first. So that's why we say we enter the data cleaning phase. So in other words, this is basically the pre-processing step. So pre-processing is done on the acquired data first. In pre-processing, we make the data clean, and most of the time is spent over here. Once the data is clean, as per the previous discussion, we split the data set into training part and the test set. Then model is built with the help of this training data set, and the build model is tested with the help of this test data set. And once we are, if we are not satisfied with the performance, we enter this loop. You can see this loop, test model to again train model. So this happens once the performance of the trained model is not up to the mark. One, we are not satisfied with the performance of the model, so we will keep remaining in this loop. And once we get the model of desired accuracy, desired performance, then we proceed with the deployment of that model. So this entire machine learning process is very clear and self-explanatory. You acquire the data, clean the data, split the data into test and training part, then train the model with the training data set, and then test the model with this testing data set, and keep on training and testing until you get the model with the desired performance. And once you get the model with the desired performance, you then deploy the model. So again, previously we talked about learning versus explicit programming, also called the designing approach. So this is a small exercise like which one should definitely go through. Yeah, this exercise just ask question like whether one should follow learning approach or a designing approach given in a particular problem scenario. So see, the exercise is, which of the following problems are more suited for the learning approach and which are more suited for the designing approach? Determining the age at which a particular medical test should be performed. So answer is very clear, like for this very application, the learning approach is more suitable. Why so? Because no explicit algorithm can be written that can tell us the age at which a particular medical test should be performed. Similarly, now if we are trying to classifying number into primes and numbers, for this AI approach is not required. For this explicit programming or a designing approach is more suitable. Why? Because the criteria like this number is prime or this number is not prime is already well defined. There are mathematical facts, conditions for that can be very easily checked. This is very well defined problem, so AI is not required. Similarly, detecting the potential fraud in credit card charges. So again, for this application, explicit algorithms cannot be deployed, and learning would be the best approach to go. Determining the time it would take for the falling object to hit a ground, and for this very task, again, designing explicit programming is required, because we have the exact physical formulas, equations available that can calculate that time, the time it would take for a falling object to hit the ground. And then last, see the application determining the potential cycle for traffic lights in a bin. Again, for this the learning approach is required. So again, irrespective of what machine learning application or project you are attempting, while you are building a learning solution, you should answer or at least keep in mind the following questions. So very important, like what questions I'm trying to answer. Do I think that the data collected can answer this question? So many a times, we don't have the appropriate data for the kind of predictive system we are building. So we must ask ourselves this question first, like we want to build a predictive model, whether the information about the learning signal is present in the data set or not. If the learning signal is not present in the data set, you cannot make the predictive model even if the data set is labeled. Next, what is the best way to rephrase my question or phrase my question as a learning problem? Have I collected enough data to represent the problem I want to solve? So again, many a time we see that the data that is required for the machine learning task is not enough. It is very small. So again, if you are trying to go ahead with the machine learning approach, try to ensure that you have the ample amount of data and learning is, applicable on that data so that the results are really generalized. Again, what features of data you extract and will these enable the right prediction? So this is another very important, question and is also the subject matter of feature engineering, where we talk about the relevant feature, irrelevant feature, important feature. So the things like feature selection, feature extraction, feature construction, feature reduction. So these techniques are utilized to get the right set of features. Then how will I measure success in my application? What are the appropriate matrices? And you will see, like for classification, we have matrices like accuracy, precision, recall, sensitivity, specificity. These can be utilized. But the same matrices can be not be utilized for a regression task, for which we require an altogether different set of matrices. So matrices like, mean square error, root mean square error, coefficient of determination, those kind of matrices become more suitable for a regression task. And clustering, unfortunately, it's very difficult to validate. Why? Because we don't have, exact matrices to judge the performance of a clustering task. The main thing is, the problem is that in clustering, data set is unlabeled. So if the data set is unlabeled, you have not left any means and mechanism available with you that can, tell you about the correctness of your clustering results. So we use indirect approaches like, say, Lodhi, score, that can tell us, some information about the quality of the clusters. So really, if we have obtained good quality cluster, that indicate a good clustering. But if we have got clusters of bad quality, that indicates a bad clustering. And there are certain heuristics like algo method that can be utilized in clustering algorithms like k-mean to come up with the optimal value of k. Because whenever we are doing clustering, in fact, the user have to tell, like in how many clusters the user want to divide the data, and user may not have any indication of the number of clusters in the data. So in that sense, clustering is really very challenging. Validating clustering is very difficult. So for classification, we have good set of matrices. For regression also, we have a really good set of matrices to judge the performance of the build model. But for clustering, it is difficult, it is challenging. And we must also ask one question, like how will the learning solution interact with other parts of my research or the business solution? This is also very important, because you have to look at the interfaces also. Like if you have trained a model, how that model would be interfaced with the other components of the overall system. This also needs to be looked into. So I will try to give you a very brief idea overview of the overall machine learning process. So I was fast just in my explaining, because I just wanted to give you the gist of the overall process. Because last 5-10 minutes I have reserved to give you a demonstration, like how you can make build predictive models with generative AI. So for this demonstration, now we would be utilizing this Google Colab environment. I'm sure that every one of you, all the participants, are aware of the Google Colab environment. So this is an environment which can be utilized for writing the basic machine learning code. Like if you are experimenting with machine learning, you want to write some code for machine learning, this code can be written in Google Colab environment. So you visit that site, click on that connect button. The system will allocate you resources, the RAM and disk, and you'll get this kind of interface, and here you can start experimenting with code. So now what I will try to demonstrate is that nowadays we can utilize this generative power of AI to do the different machine learning tasks. So in the slides, if we look at the different machine learning, like data acquisition, data cleaning, training, all these steps can be automated. All these steps can be done with the help of this generative AI. So for this, I'll give you a very basic demonstration. Like you all might be knowing that there is an iris data set available in scikit-learn. So in Google also, if you search toy data sets in scikit-learn, you will see Scikit-learn is a machine learning library. Scikit-learn is a Python machine learning library. And if you look at the toy datasets available in this, you'll see we have the datasets like load iris, load diabetes, digits, uh, then this physical exercise related linear data sets, wine data set, breast cancer data set available. So few data sets are suitable for regression task, few data sets are available for classification tasks. And this is small demonstration will demonstrate like how generative AI can be utilized, can be used to execute this machine learning task: data acquisition, cleaning, training, splitting the data into test data set, and then testing the model. So it is very simple. You just need to give the appropriate prompt to the system. For example, here if I say to the system that you simply provide the code to read iris data set, so system will automatically provide you the code. Like you see, very beautifully, the system has, loaded the iris data set, and it has written certain, statements like, you can see the shape of the data. It will give you the feature name, target names, data and the target values. So automatically it has generated the code to, read the data set. So if you'll run this code, uh, see, the system has outputted that your dataset consists of 150 rows, 4 columns. The features are sepal length, sepal width, petal width, and the targets are three basically classes: the Stosa, versicolor, and Virginica. And this is the sample, instances from that data. Now, again, if we look at this, standard pipeline data acquisition. So in this case, because we were using toy data sets, we simply asked the system, you provide me the code to read the iris data set, and this system has given the code. Now you consider a situation here, your data set is in Excel file. So if you give the prompt select provide code to read dash 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 CSV file, then system can generate that code also, and provide code to read, let's say XLS or any PDF file or any other file, then system can generate appropriate code. The point I am making is that with generative AI, for simple projects, machine learning projects, this process can be very easily executed with the help of generative AI. Now, number two, second phase is data cleaning. Now, if we consider this very data set, the iris data set, this is very simple and small data sets already available in scikit-learn, and it is already clean. So it is not a dirty or noisy data. So in this very case, this process data cleaning is redundant. So I will not be performing. But anyways, in your case, if you are dealing with the dirty data or the noisy data, then you can provide prompts like provide code to remove remove rows with missing values in data set dash dash dash. So these kind of prompts can be given, and system will automatically give you the code, like provide code to remove rows with missing values in that data set. And similarly, if you want to handle the inconsistent values, you want to delete certain rows, you want to delete certain columns, you want to remove irrelevant column. For example, let's say you find that there is an ID column in your data set, and ID is not a relevant attribute if you are utilizing that data set for learning. And similarly, let's say there is a gender column, and again, if you are doing you're doing let's say such a classification task which is independent of the gender of the person, then gender column needs to be removed. So accordingly, the prompts can be generated. Okay, provide code to delete this attribute or this rows from that data set. So that cleaning part can also be very easily attempted. Now, in my case, the data set is clean. Now here, because the next step is to split the data set into the training part and test part. So we can simply give a prompt to collab, like split this data set into training and test part. So you see the system will, give you that code also. Automatically it has, imported the required, library train test split, and it has, made a call to this train test split function, and it has automatically passed the iris data, the test size at 30%, and 70% of the data it has reserved for training. And now if you execute this code, you'll see this code will work fine, and automatically the splitting into training and test part has happened. Now, if you simply say, okay, you generate, apply logistic regression on this data set and display accuracy. So see, system will automatically apply logistic regression, which is a classification model, and see the display the accuracy. You see, automatically, the system has imported the library, it has applied the logistic regression and given you the accuracy. Now you see, if I ask, okay, you provide top 10 algorithm, top 10 classification algorithm on this data set and display accuracy in the form of bar graph. So see, otherwise it's a very big task, applying 10 different classification algorithm and displaying the accuracy in the form of a bar graph. Now see how beautifully the generative AI has, generated the code. It has, identified the 10 suitable classification algorithms. Then it has, repeatedly apply them, and it is plotting the results also, accuracy results also. Let's execute this code and we will see the 10 algorithms, like the logistic regression, SVC, decision, random forest, gradient voting, KNN, Gaussian naive, linear discriminant analysis, quad discriminant, MLP classifier, they have been applied, and the system has reported their accuracy also, and it has plotted these accuracy also. Not only this, if you ask the system, okay, you apply SVM and choose the best model uh, with uh, grid search and cross validation approach. So I'll give a basic idea, like I want to apply grid search and cross validation, and I want to apply this grid for search and cross validation to select best SVM model. Then you see system has automatically identified the hyperparameter of SVM, like the C value 0.11, 10, 100, the gamma values, the kernel values, radial basis function, polynomial, sigmoidal, and automatically it has applied SVM and is applying grid search, and it is trying to select the best combination of these parameters, and then it is reporting the accuracy. Now because there are 1 2 3 4 4 C parameters, 4 gamma parameters, and 3 kernel parameters, so 4 into 4 16, 6 into 3 48, 48 different models the system will prepare, and it will give you the best model. So in my system, it will take time. So let's reduce some of these parameters, and then let's experiment. We are experimenting only with RBF and polynomial and these values. So now if you'll run this code, you'll see in the output system will say that it has worked with all these combinations, and ultimately now it has found that the best parameter, sorry, the best parameters are this thing, that is C10, gamma 0.1, and kernel RBF, and the best score is 0.98. Accuracy of the best CM model is this. Not only this, but if you see, you provide code to cross validation, code to select best classifier out of 10, then it will apply cross validation in that sense also, because cross validation can be applied in this sense also to select the best model out of these different classification models like logistic, SVM, decision tree, random, and this thing. And you see here the system automatically has applied the grid search and cross validation score also to select the best model. So this also, if you will run, the code must work fine, and the system has said that logistic regression has worked fine. SVS, mean cross validation accuracy, okay, yes. So for each of these models, logistic regression, SVM, decision tree, random, the system is giving you the best cross validation accuracy. And in the next code segment, so similarly, if you extend the notion, you make a prompt like you make a bar chart comparison of their accuracy value, precision values, F1 score values, or recall values, or sensitivity values. So again, all these plots can also be prepared just with the help of that prompt. So the point I am making is writing code is not a problem nowadays, provided you have the good understanding of the concepts. So if you have a conceptual understanding of the problem and its solution, then writing code, generating code is not a difficult task nowadays, because nowadays we have the access to tools like these generative AIT. You just need to specify your prompt very precisely to the system, and system will automatically give you the code. So this point I just wanted to highlight with all the participants. If we talk about the basics of machine learning, that the process is really very much straightforward: getting the data, cleaning the data, splitting into training, testing, then just the performance of the model, fine tune the model until you get the model with the desired accuracy, and then finally deploy this model. And applying different classifier, regression model, clustering model is not a difficult task nowadays. We have access to generative AI kind of tools. They can very easily automate the process, provided we have a good understanding of the process. So similarly, for this application, if we have taken, let's say, some clustering data set, and if I prompt the system, okay, you apply hierarchical clustering or k-means clustering, then you apply some heuristic to come up with the best number of cluster or best value of k, and then you give us some means and mechanisms to comment on the to display the goodness of a particular cluster or a field. Then this generative AI can span other dimension, other fields as also, and really give you a very good set of heuristic, like what is the goodness of results in your clustering, in your clusters that your algorithm has produced. So the point I am trying to make is that then generative AI is really very powerful, because writing code manually is difficult, prone to errors, and again your logic may be limited. The access to heuristics may be different, but if you are really using generative AI, then it can broaden the horizon, and provided that we have a good knowledge of the process, like what we want to achieve, or what we want to do, generative AI can really come to our help. So with this, I'll finish this talk also. I'll stop the presentation. Now over to you participants for your comments and queries for this session, for machine learning session. Yes, over to you participants now.
So, dear participant, is there any question you may ask?
Thank you for the wonderful session, sir. And the participants, you can drop the message in the chat box if any query you do have.
Thank you so
Sarbjeet,
much,
sir.
sir, for a wonderful session.
Sir, there
Good
is
evening,
query
sir.
from one student. How might advancement in quantum computing impact the field of AI and ML?
Quantum computing, in my opinion, will not become a reality in the near future. See, because as far as my knowledge is concerned, see, quantum computer, they use the concept of qubit. See, if we want to utilize quantum computing for doing computations, then they are relying on the concept of qubit, which is basically, the different states of the atom. So at present, I don't think that we have built such physical system that can implement qubits. And if we have not built those physical system which can implement qubit, so realizing quantum computer is very difficult. It is kind of impossible. So maybe 5 to 6 year down the line also, I don't see that quantum computers will become a reality. The concept is very promising. The concept has a lot of potential, provided that we are able to realize qubits. So till the time we are not able to realize qubits, we are not able to build those physical machines which can realize qubits. It will just remain a kind of vague kind of term. Probably it will not become a reality in the near future. The quantum computers, the concept is good, but practical realization is very difficult, very difficult. This is what my knowledge is about this concept of quantum computing.
Sir, good evening.
Yes, good evening, sir.
What measures can be taken to ensure ethical AI development and deployment?
Pardon, sir, I didn't get you.
What measures I already type in command box, send in
So
command
what
box. What
measurements
measures?
can be taken to ensure ethical AI development and deployment?
Okay, so for that, what we can do, we can, educate the audience. We can educate the practitioners in this regard. So probably that is the only, because uh, making someone learn about the ethics is very difficult, very difficult. And the concept of ethics is also very subjective and differs from person to person. And again, how it deals needs to be dealt. I think for that, some kind of training is required, wherein persons from different disciplines, maybe from law, from psychology, from social sciences, they can come up with certain policies and train the practitioners. So in that way, this ethical AI can be dealt with.
Sir, one more question.
Yes, please.
Why are you consider threats considered as dangerous as external cyber threats?
Pardon, sir.
Why are insider threats considered as dangerous as external cyber threats?
See, insiders may also be a threat to the system, because insiders have some knowledge of the system. Insiders have access to the data set, to the data. So if insiders have access to the data, insiders have some knowledge of the system in their mind. So that can be exploited. That can be misused. So in that sense, insiders is also a threat to the organization, or to the cyber security system.
Good evening, sir.
And one more last question, sir. One more
Yes,
last
please.
question. Why is
Sir,
the quality and quantity of data crucial of the success of AI and ML systems?
And please come again, sir.
Why is the quality and quantity of data critical of the success of AI and ML systems?
Yes, definitely. Because see, data is something which you are using in machine learning systems for training purpose. And let's say your input data is not of required quality or quantity. So if the input data is not of required quality and quantity, the learned model would also not be appropriate. And whatever outputs it is that learned model is producing, they cannot be relied upon. So because everything depends upon the quality and quantity of the data. If the input data is wrong and a model has learned the wrong data, obviously the prediction that it would be making would be wrong. So in that sense, again, it is the responsibility of the practitioner or each and every stakeholder, whosoever is concerned with the connected to the machine learning process, to ensure the quality as well as the quantity of the data.
Thank you, sir. Thank you. It's really useful for us. Thank you.
Yeah, welcome.
Sir, there are lots of appreciation for your expert talk.
Thank you, Pankaj.
Sir, some of the participants have inquired about the resources as the candidates will have to appear for the quiz and the end of
Okay.
this FDP. So
So,
some
sir, by
resources.
tomorrow, I would be sharing the PPTs with you, and that you can further share with the participants.
Right, sir. And other resources, if any web links that you could suggest,
Sir, I will
that would be
embed
great.
those resources in the PPT only. So I'll
Right.
give them the PDF version, and
Right, sir.
that PDF version will include the web links also.
Right, sir.
Sir,
Right.
also please share the collab link, sir, if possible.
Okay, we'll do
And
that.
thank you so much for a wonderful session, sir.
Yeah. Thank you.
Will you provide your email address, sir? If you have
Yes.
any other doubts, I will ask too.
Yes, this is sarbjeet@pu.ac.in, SARBJEET@pu.ac.in.
Sarbjeet sir, thank you,
Thank you,
sir.
sir.
Your
Thank you.
presence
Thank you. Thank you, sir.
Yeah.
good.
Thank you, sir. Thank you.
And your voice and audio quality is really amazing. And I think it has looked like a podcast or radio stations I'm listening. So I
Sir,
appreciate it.
last request, sir, if possible, please turn on your video, sir. We want to see you, sir.
Okay, just 1 minute.
Thank you, thank you.
So hope my face is visible now.
Yes, sir. Yes, yes. Visiting. And thank you very much, sir. Such a
You're
late night.
welcome,
You are
sir.
doing
Welcome.
great job. And we really appreciate your hard work, sir.
Thank you.
Thank you, sir.
Pankaj, sir, you can close the session.
Yes, sir. Sir has clarified all the doubts of the participants. So it was a very informative session, sir. You bounded the participants in this online mode. It's very tough. I repeat again, it's very tough to bound the participants, but with the very melodious voice, as one of the participants has, it was a podcast demonstration. So, sir, politeness is there in the sir voice. So it was a wonderful session, sir. It's always wonderful to interact with you. It's a always knowledgeable session whenever we do interact with you, sir. So thank you so much, Sarbjeet sir.
Thank you very much, sir. My pleasure all.
And we expect you to see you physically in the next Board of Studies meeting. Thank you, sir.
Sure, sir. Sure. Thank you. Thank you very much. Thank you.
So, Singla sir, now we can close this session.
Yes, sir. We can close now.
And so
We'll
all the
again.
participants are again requested to fill the feedback form. So the both session feedback forms are shared in this meeting chat. Kindly don't send the personal messages about to inquire about the feedback links. We will communicate at most of the times we will communicate through the chat right here. And kindly don't send personal messages because we are sharing the complete information on this platform.
Pankaj, sir, but I can't see the link. If you can resend it in chat itself so that we can fill the feedback.
Okay, sir, I will send it again.
Thank you. Thank you very much, sir.
Pankaj sir, we need to wait for 5 minutes.
No, sir, we can close the session. So we will meet, we will interact every day for the
Sir,
next
I
5
request
days
you
as
wait
well.
for 5 seconds because maybe link we will not able to access if meeting get closed.
Okay, you can assess it, sir.
Thank you, sir.
We will wait for the 5 minutes.
Thank you so much, sir.
Sir, I want to announce one more thing. All the PPTs and documents will be shared in the Atal portal. So all of you are having your credentials with you.
So major set of the research articles from the renowned publications like Science Direct, they are already published on the Atal portal. So kindly try to utilize those resources, and whenever we are getting the updates from the presenters, the experts, so we will update there at the Atal portal.
Sir, the feedback is only for section 2 or it is for both session?
Sir, there are two web links. Both feedbacks are independent. Session
Sir,
1 has a different web link.
So if you can share section 1 also, because I can see only section 2 only.
Okay, thank you everyone for your patient listening, and we expect your full anticipation in the coming sessions as well. So see you tomorrow as per the schedule. Kindly log in and anticipate in every session so that this program could bring a fruitful results. Okay, thank you so much.
Thank you,
And good
Pankaj sir.
night.
Thank you, Singla sir. Great. Have a good night, sir. Thank you.
Okay, Singh sir, now we can close the session.
Okay, sir. I'm going to end the meeting. Thank you.